Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 31st sum. Already in the last videos, I have uploaded solutions till 30 sum, so please do check it. Now let's start with the 31st sum. Show that the function defined by f of x equal to cos of x square is a continuous function. So they're asking us to prove that the given f of x is a continuous function. So here indicated point is not given. So we have to prove it throughout the real line the function is continuous. Okay, and the given f of x, if you notice, no, this f of x is the combination of two functions here, cos of x square, right? So it is actually combination of two functions. So first I am going to explain how it is combination of two functions, then we can prove the how f of x is continuous. Okay, so now let me take g of x as a cos x and h of x as a x square, and we studied about the composition of functions in the first chapter. So their composition of g and h. Okay, and so g composite of h is, this can be rewritten in the form of g of h of x. So now inside the bracket, what is that? We have h of x. So let replace h of x as a x square. Okay, then we got it like a g of x square. So what is a g of x here? If input is x, outcome is cos x. So whatever input we give, it is converting in terms of cos. So if input is x square, it will come as cos x square. So that means this is the basically f of x, right? This is the given question. This is what? Combination of two functions. Now we have one property in the continuous continuity, that is when two continuous functions are combined, still those are continuous. So instead of proving f of x is a continuous, f of x, that is cos x square, is a continuous, we are going to say g of x is continuous. We are going to prove h of x is continuous. Then f of x is what? G of h of x only, no, f of x. Then obviously f of x is also continuous. So this is how we are going to proceed the sum. Okay, so now first I am going to say the g of x is continuous, that is cos x is continuous. So cos x is continuous for all real numbers we have to prove. So I am going to consider, let c be the any real value. To prove the continuity, we need three stuff, but that is f of c, left hand limit and right hand limit. If all the three results are equal, then we can say at c the given function is continuous. Here given what is the function that we are assigning? G of x, no, g of x only. First we are going to prove it as a continuous. So that is we need g of c, left hand limit, right hand limit. All the three things we have to find out. Okay, now let c be any real value we have taken, right? Now what is the g of c? G of x is cos x. If input is c, then this will be changing it as a cos c. Okay, so c be any real value, right? So first we found the g of c value. Now left hand limit, let's find out. Left hand side closed values of c are less than c. Okay, so left hand limit x is approaching towards the c from the left hand side, and g of x, the suitable g of x, what is the g of x here? Cos x, no. So let me replace g of x as a cos x. Okay, now here the closed values of the c are approximately c, but those values are less than c. So for less than c, I'm going to make a substitution x as a c minus h. Okay, so where h is the interval differencing. So let me explain that. Suppose if I have a 5 here. Okay, so then the left hand side closed values of 5, very close values of 5 are approximately 5, but those values are less than 5. For sample, like 4.99, 4.9998, so such type of value. So that means 0 point, some point value is differing, from the 5. So that one balancing only we are going to take x as a c minus h, interval differencing. In case if I am taking the right hand side, no, right hand side closed values are greater than c, approximately c, but those are greater than c. So while finding the right hand limit, I am going to make a substitution, x as a c plus h. This is only for trigonometric functions. Okay, so now I am going to replace x as a c minus h. Okay, now interval also it will change. Here x is approaching towards the c, right? That means we are going to make a substitution x as a c. Let's replace x as a c here. C equal to c minus h. Then c minus c equal to minus h. Then c minus c is 0 minus h. That means h equal to 0. H is approaches to 0. So if x is approaches to c, h is approaches to 0. Now, in a trigonometry, we have a expansion for the cos of x minus y. So using that, we are going to expand cos of c minus h. So now limit h is approaching to 0. Cos of x minus y formula, cos a cos b. That means cos c cos h plus sin c sin h. Okay. Now let's apply the limit. So in place of h, if we replace the 0, then cos c cos 0 plus sin c sin 0. Sin 0 value is 0. Okay. If 0 is getting multiplied with anything, the total term becomes a 0. Here cos 0 value is 1. Okay, cos 0 value is 1. Now 1 is multiplying with anything, the same term, that is cos c. So here we are getting cos c. Okay, so what is the left hand limit value? Cos c. Now similarly, we are going to find out for the right hand limit as well. Now limit x is approaching to the c from the right side, that is g of x. For the g of x, what is the g of x here? Cos x. Now replacing g of x as a cos x. As I told you before, right side closed values are approximately c, but those are greater than c. So for that, I am going to make a substitution in place of x as a c plus h, where h is some interval differencing. So now if x is approaching to c, h is approaches to 0. I already explained here the same concept only. H is approaches to 0. Now cos of c plus h. Now using cos of x plus y formula, I am going to expand this. Then I am going to apply the limit. That is cos a, that is cos c plus cos h minus sin c into sin h. Now let's apply the limit. So cos c cos 0 minus sin c sin 0. Okay, sin 0 value 0, then entire term becomes 0. Cos 0 value 1, 1 into anything, cos c. So what is the right hand limit that we got? Cos c. Now from the above result, g of c, left hand limit and right hand limit, if you notice, g of c, left hand limit and right hand limit values are same. So from this we can say g of x is, that is g of x is what? Cos x. So g of x equal to cos x is continuous for all real values. For all real values. Okay. So the given function is combination of two functions, that is one is cos x, other one is x square. Now similarly we are going to prove it, that is x square is also a continuous function. Okay. So h of x is a continuous. So now we have let h of x is what? X square. So we have to prove that h of x is a continuous for all real values. How many real values we have? Infinite real values we have, no, in a real line. So let c be the any real value. Any real value. So to check the continuity, we need three things, that is h of c is required, left hand limit and right hand limit. Okay. So what is the first h of c? If input is c, then outcome is c square. Now left hand limit, and left side closed values and right side closed values of c, same for the left hand limit we are going to use the same function. Instead of finding left hand limit, right hand limit separately, together itself we can find out limit x is approaching to the c, h of x. So what is the h of x here? H of x is x square. Now applying the limit, what we will get? C square. So that means you can notice that h of c value limit x is approaching to the c, h of x value both are same. So from this what we can say, h of x equal to x square is a continuous function. Continuous for all real values. Okay. Continuous for all real values. Now we got the two results. Here we found that is g of x equal to cos x is a continuous. Here h of x equal to x square is a continuous. So that means we have g of x equal to cos x is continuous. Okay, continuous for all real values. Similarly, h of x equal to x square is continuous for all real values. Okay. Now combination of two continuous functions are continuous. That is g of h of x is also continuous. That means what? F of x equal to cos of x square is continuous for all real values. Okay, hence proved. That's all the proof of this particular sum. Thank you for watching and please do subscribe. Thank you.